professor at LG Institute of Engineering and Technology. Today we are going to study few more topics of system of linear equation and matrices. So let's begin with the first topic, that is system of non-homogeneous linear equations. The system of m non-homogeneous linear equation in n variable x1, x2 up to xn is a set of m linear equation each in n variables. So a linear system is represented by a11 x1 plus a12 x2 plus a1 n xn is equal to b1 and so on up to am1 x1 plus am2 x2 plus amn xn is equal to bm. Okay, so here we have m linear equations, right? And we have n variables. You can see here we have m equations and we have n variables, and the system we have represented like this. Now we will write this equation in the matrix form as ax is equal to b, where a is equal to a11, a12 up to a1n and so on, am1, am2 up to amn. Okay, this is called a coefficient matrix of order m cross n. Okay, now x is x1, x2, xn. This is any vector of order n cross 1, and b is equal to b1, b2 up to bn is any vector of order m cross 1. Okay, now let's study the solution of system of non-homogeneous linear equation using Gauss elimination method. So for a system of n linear equations in n variables, there are three possibilities of the solution. The first one is system has a unique solution. Next, the system has infinite solution, and the system has no solution. Okay, so when the system of linear equation has one or more solution, that is the system has a unique or infinite solution, right, then we can say that the system is consistent. Okay, and if we have no solution, then we can say that the system is inconsistent. Okay, now the matrix A is to B, that is A11, A12 up to A1n is to B1 and up to AM1, AM2, AMN is to Bn. Okay, so this is called augmented matrix of a given system, right? To solve the system of a linear equation, elementary row operations are used to reduce the augmented matrix to either row echelon form or reduced row echelon form. Okay, so what we have to do, we have to reduce this augmented matrix form either in the row echelon form or in the reduced row echelon form, right? So reducing the augmented matrix to row echelon form is called Gauss elimination method. Okay, so if we reduce this augmented matrix to a row echelon form, then this method is known as Gauss elimination method. Okay, now let's study the Gauss elimination method for solving non-homogeneous linear system. So the first step is we have to write the augmented matrix form. Okay, then we have to obtain the row echelon form of an augmented matrix by using row operations. Okay, next we have to write the corresponding linear system of equation from row echelon form. So firstly we will write this augmented matrix form, okay, and then we will find the row echelon form, and from that we will write again the system of this linear equation. Okay, and at last solve the corresponding linear system of equation by back substitution, and then we will solve this equation using back substitution method. Okay, so let's begin with this example. Solve the following system by Gauss elimination method. The equations are x plus y plus 2z is equal to 9, 2x plus 4y minus 3z is equal to 1, and 3x plus 6y minus 5z is equal to 0. Okay, so let's begin with the solution. Firstly, we will write the matrix form of the system. Okay, so firstly consider this coefficient, that is 1 1 2. So here we will write 1 1 2. Then 2 4 minus 3. So 2 4 minus 3, and from here 3 6 minus 5 here. Okay, into capital X, that is the variable. So here we have x y z variable. So we will write x y z is equal to, here we have to write this constant, that is 9 1 and 0. Okay, so this is our matrix form of the system. Now we will write the augmented matrix form of the system. Okay, so we will write as this matrix A is to this B, that is 9 1 and 0. Okay, now the next step is to reduce this augmented matrix to row echelon form. Okay, so here we have leading 1 over here. So the first step is what? We have to make 0 at these two places. Okay, now here we have 2 in the second row. So we will write R2 minus 2R1 and we will make the changes in R2. And to make the third row 0, we will write this R3 minus 3R1 and we will make the changes in R3. So you will get 1 1 2 9 0 2 minus 7 minus 17 0 3 minus 11 and minus 27. Okay, now here we have zeros. Now the next step is to make 1 over here. So what we will do, we will divide it by 2. So you will get 1 by 2 R2, that is this first and third row will remain as it is, and we will get change in the second row, that is 0 1 minus 7 by 2 and minus 17 by 2. Now here we have leading 1. So the next step is to make 0 over here. So this is the third row and here we have 3 numbers. So we will write as R3 minus 3R2 changing R3. Okay, so you will get this first 2 row will remain as it is, and here we have 0 0 minus 1 by 2 and minus 3 by 2. Okay, now the next step is to make 1 over here. So what we will do, we will multiply it by minus 2. So minus 2 R3, right? So multiply it by minus 2. So you will get this first and second row will remain as it is, and here we have 0 0 1 and 3. Okay, now this is our row echelon form. Here we have this leading 1 and we have 0 below to the leading 1. Okay, now we will write the system of equation from this. So you will get x plus y plus 2z is equal to 9 from the first row. Then y minus 7 by 2 into z is equal to minus 17 by 2 from second row, and z is equal to 3 from the third row. Okay, now what we will do, we will substitute this z over here and also z over here. So if you will substitute z over here, you will get y, and when you will substitute y and z over here, you will get x. So this method is known as back substitution. Okay, so let's put z is equal to 3 in the equation number 2. So you will get y minus 7 by 2 into 3 is equal to minus 17 by 2. Simplify, so you will get y minus 21 by 2 is equal to minus 17 by 2. On further simplification, you will get the value of y as 2. Bring this minus 21 by 2 here. Okay, so minus 17 by 2 plus 21 by 2, that is 4 by 2. So you will get 2. Next, we will substitute this y is equal to 2 and z is equal to 3 in our equation number 1. So you will get x plus 2 into 3 is equal to 9. Okay, simplify, so you will get answer of x as 1. So in all we had x is equal to 1, y is equal to 2 and z is equal to 3. So this is the solution of a given system. Okay, you can see we have only one answer for x, y and z. So this solution is known as unique solution. Okay, next, solve the following system by Gauss elimination method. Equations are 3x plus y minus 3z is equal to 13, 2x minus 3y plus 7z is equal to 5, and 2x plus 19y minus 47z is equal to 32. Okay, so let's begin with the solution. Firstly, we will write the matrix form, that is Ax is equal to B. Okay, so for A we have to write this coefficient, that is 3 1 minus 3. From here 2 minus 3 7, and from here 2 19 and minus 47. Variables are x, y, z, so write down x, y, z here, and equals to this constant, that is 13, 5 and 32. Okay, so write down here. Next we will write the augmented matrix form, that is A is to B. So this matrix A is to this matrix B. Okay, now the next step is to reduce this augmented matrix form to row echelon form. Okay, so here we have to make 1. So for that what we will do, we'll divide it by 3. So 1 upon 3 R1. You will get 1 by 3 minus 1 13 by 3. And this second and third row will remain as it is. Okay. Now the next step is to make 0 over here. Okay. So we will use the operation here. This is the second row. So we will write R2 here 2. So minus 2, and leading 1 is in the first row. So R1, and changes we will make in R2. Okay. Then to make 0 over here, we will write R3 minus 2R1, and we will make the changes in third row. Okay. So this first row will remain as it is, and we will make the changes in second and third row. So for that what we have to do, we have to multiply by minus 2 in this first row and add to this second row. So you will get this form. Okay, and again we have to multiply it by minus 2 and add in this third row. So you will get this form. Right? Now the next step is to make 1 over here. Okay, so what we will do, we'll multiply it by minus 3 upon 11. So minus 3 upon 11 R2. So you will get this first and third row as it is, and here we have 0, 1, minus 27 by 11 and 1. Right? Now the next step is to make 0 over here. So for that we will use the operation. Here we R3. So R3, and here we have 55 by 3. So we will write minus 55 by 3 into R2. So what we will do, we will just multiply by minus 55 by 3 over here, and we will add in this third row. So you will get this first two row as it is. So here you will get 0, 0, 0 and 5. Right? Now we will write in the equation form. So from the last row of that matrix, we can say that it is 0x plus 0y plus 0z is equal to 5. So this means 0 is equal to 5, which is not possible, right? So the given system is inconsistent and we have no solution. Okay. So in today's session, we studied this Gauss elimination method. Okay. So what we have to do? Firstly, we will write this augmented matrix form. Okay, and then we will reduce it to row echelon form. Okay, and after reducing it to row echelon form, then we will write this system of equations. Okay, and then we will find the values of, suppose we have x, y, z variable. So we will find the values of x, y, z using back substitution method. Right? So after getting the values, we have total 3 types of solution. First is you can get a unique solution. Okay. Next, you can have infinite solution, and the third one is no solution. Right? So I hope you have understood in this session. Thank you for watching.